Hi, I'm Mohammad Sharifur Rahman. I'm with Dr. Pratipanya from Ulster University. I've done research. The title of the research is Evaluating the Performance of Common Machine Learning Classifiers Using Various Validation Methods. The objective of this research is to find out the best possible mix of machine learning classifiers with different validation methods to get the best result from the machine learning model. So why we have done this research? Nowadays, many industries, including healthcare, banking, retail, manufacturing, transportation, and more, use machine learning models. And machine learning models are employed in the healthcare industry to identify diseases and forecast patient outcomes. We have used the data source of UCI machine learning repository. The name of the data is the wine database, and we used Python, Weka, MS Excel, Jupyter Notebook for the graphical user interface. And for the performance adjustment, we have used confusion matrix. And this is the achievement. We have successfully achieved 100% accuracy, precision, recall, and F1 is in prediction. We have identified the following things like decision tree, net bias, and random forest achieved 100% accuracy with the holdout validation technique. Random forest achieved 99.06% accuracy with the K-fold cross validation technique. Random forest achieved 98.12% accuracy with the leave one out cross validation technique. So this is the data set. We had 13 different features. These data are from the chemical examination of three different Italian cultivars cultivated in the same region. The research detected 13 components in all three wines, and these 13 components are our 13 features of this dataset. And data quality was good. There was no null value, no invalid value also. We had 178 observations, and the dataset had class imbalance. We 59 observations for class 1, 71 observations for class 2, 48 observations for class 3. Later we had to make class balance. So this data processing was required. We followed the standard procedure of data processing. So we collected data, analyzed it, balanced the data. We prepared the model, but we did the feature selection for this research. We visualized the data and we concluded with some results. So this is the figure. You can see there is a class imbalance. There are three classes, and all three classes are different number of observations. So we have to use smart function to generate some synthetic data, and later we had 71 observation for all the classes. So our experiment result or classifier performance for holdout technique is like this. We utilize holdout cross-validation for all the classifier models, splitting the data into 10 is to 90, 20 is to 80, 30 is to 70 in this way, 90 is to 10 up to 90 is to 10 ratios for training data versus test data. Since outcome of the study, you can see with all five classifiers, we first used percent of our data as training data, and we get accuracy of 93.23% for the k nearest neighbor classifier. For tree, we got 65.10. For net bias, it's 92.19. For SBM, we got only 34.38% accuracy, and for the random forest, we got 84.90% accuracy. Then we used 20% of our data as our training data. In this way, we used 30%, 40%, 50%, 70%, 60%, then 70% as our training data. And we could see that when we use 70% of our training, 70% of our data as our training data from the whole data set, we got the highest possible accuracy. Like from k nearest neighbor, we got 98.44% accuracy. For decision tree, we got 96.88%. For naive Bayes, 100% accuracy. For HVM, it's 50%. Random forest, it's 100%. If we can see that for most of the cases, when we use more data as our training data, the accuracy rate doesn't improve. Sometimes it also decreases, sometimes it keeps same. For only decision tree, we got 100% accuracy when we used 90% data as our training data. And for SVM, the accuracy rate is not good also. So we can come to a conclusion that pulled out cross-validation technique, 70% data as a training data is the best possible pulled out technique we can use for any of the classifiers. If we use k-fold cross-validation technique or leave one out cross-validation technique, we get this table. We used 2, 5, 10, 15, 20, 50 and 100 folds for all the classifiers and 213 fold for the leave one out cross validation technique to get the result. So if you can see that if we use two-fold cross validation technique, we get this result here. K nearest neighbor it's 96.71, for decision tree 93.90 and so on. But if you see data, the accuracy rate grows till tenfold. If you see that after tenfold it didn't grow, if you see that in the decision tree it's 94.84% accuracy, and if you use 15-fold, 20-fold or 5400-fold, you will get the same accuracy rate. And for naive Bayes also you will get same accuracy rate. And for random forest it decreases sometimes. So for k-fold validation we have found that 10-fold validation is the base for this type of validation technique for classifiers. Using the best possible combination of cross validation performance for all 5 classifier models, we discovered the data in the table below. We see this result. We saw that for holdout technique, 30% data holdout was the best performer in our case, and for k-fold, 10-fold was the best performer. For leave one out, we got this result. We can see that random forest classifier always had reputation of accuracy rate. We can see that random forest classifier can get up to 99.06%. If we use holdout technique, it can go up to 100%. We use a confusion matrix to assess performance of the classifier. So if we the accuracy means all true positive and true negative over all true positive, true negative, false positive, and false negative. And the precision is all true positive over the true positive and false positive. And recall is the true positive over the true positive and false negative. So the kind of dataset is essential to determine which metric is needed to evaluate a model performance. Precision is the likelihood that an observation is positive when a classifier predicts it to be positive. Recall presents the likelihood that a positive observation will be recognized, and the mean of precision and recall is F1. In this example, the wine dataset is a type of dataset that allows us to make decisions without bias. The F1 score is the better measure for assessing the model performance for this data set. The table displays assessment score of the classifier models. The random forest and the naive Bayes classifier models were determined to have the best fit for this dataset. If you can see that this is the F1 score, yeah, we can get up to 100% of F1 score for naive Bayes if we use 30% holdout of data. And for the random forest also, we can go up to 100% accuracy. Sorry, 100% F1 score, and decode rate is also 100%. For random forest, if we use 30% holdout technique. So this is the best possible way to result from the classifier. So the conclusion is when using the holdout validation technique, decision tree and random forest must use at least 30% of the data as a training set to achieve acceptable output accuracy. The best results were achieved when 70% of data was used for training. When using the k-fold validation technique, more than tenfold were unnecessary because performance improvement stops after this point. Random forest and naive bias outperformed the competition. According to our analysis, our cross-validation technique, where 70% of data were used for training, is the best. We have scope of future work. This database set was a small one. We can use a big, and also we can use more classes to check if the performance of the classifiers is matched with our research or not. So for the recommendation, the data set we employed was the modest one. So a large data set will enable us to better understand our experiment. So that's all from. Thanks for listening.